Alright, good morning. This lesson is for my honor students. Happy Tuesday. Is it Tuesday? March 18th. No, March 17th. March 17th. Tuesday, March 17th. I just need to check something really quick. Okay. So just a couple housekeeping notes. First of all, I don't get to teach on campus anymore. I'm teaching out of my house. Notice there's blue here instead of my tray for my pens, so I can't have a tray of pens with different color lids. The lessons will still continue. I did watch the lesson that I presented yesterday. There was a couple things I actually did make a mistake. I misused the word conjecture. I should have used the word postulate. I will explain what a postulate is a little bit better. And I didn't articulate what the corresponding angle postulate was. I felt is good enough detail. I also recognized or noticed that I say the word a lot. I'm going to try and cut that out. I'll keep that in my head and hopefully I can do a much better job with that. If there's any questions on anything, you can ask me through the Remind app or you can ask me by my email. And I will get back to you as soon as I can. Again, remember, I will actively answer emails or Remind app questions on between the hours of 8 and 2, Monday through Friday. So I'd like to do today's lesson, but before I do, let me just talk briefly about what a postulate is. Okay, so a postulate, and I'm going to make sure that I can, that's in, okay. So a postulate is a concept it's something that we accept as true. It can't be proved false. It's a truth. And so yesterday, we had the following postulate, which I call the corresponding angle. Converse is the corresponding angle postulate. That's a terrible S. So the corresponding angle postulate simply says if two lines are parallel, corresponding angles are congruent. I'm going to say congruent / equal. Alright, so let me just briefly talk about this for a second. So if two lines are parallel, and remember we have to put a symbol on these lines to indicate that they are in fact parallel. And am I writing too high? I'm not used to this. I wrote too high. So these lines are in fact parallel. The corresponding angle postulate is saying that since these lines are parallel, if I was to draw a transversal through them, it's literally saying that these angles must be the same because these lines are parallel. And it makes sense because the line is interacting with basically the same line. They're parallel. So there shouldn't be any difference. These should be the same, these should be the same, these should be the same, and these should be the same. I'm probably repeating myself. So that's what we accept as true. Now today's lesson is pretty simple. I'm going to lecture on 19.3. And I'd like to, I would like to write down our goals here. And our goals are going to be to use the converse of the corresponding angle postulate and create facts about lines when the corresponding angles are congruent. So let's see here. So we're going to goals. The first thing I'm going to discuss is I'm going to discuss the concept of a converse. The second thing I'm going to discuss is going to be the corresponding angle, or the converse of the corresponding angle postulate. Sorry. And the last thing we're going to talk about, the final thing, is we're going to discuss what this does, the implications. Okay. So let me start off with the first concept, the concept of a converse. And it's really easy. I'm not talking about the shoe. I'm actually talking about the order of a statement. What it does is it switches the order of the statement. So, over here in the corresponding angle postulate, I have two very important words in terms of a mathematical statement: if and then. And so what I'm actually going to do is the converse of this switches the order of the statement. So I'm going to switch the part of the statement that's with the if with the part of the statement that's with the end. And what you do is you change the order of the statement. Now sometimes this creates a truth, and sometimes it creates something that's false. But in this situation, it creates a truth. So, again, converse, like I said, is very simple. You're just literally switching the order of the statement. Okay, so I'm going to check that off. All right, and the converse of the corresponding angle postulate will be the following. And again, remember, postulates are things that we accept as true, not conjectures. Conjectures are statements that we base on a pattern. Postulates are what we accept as true. So converse of the corresponding angle postulate, not postulates, postulate. And it says the following. Remember, I'm just going to switch this. So if corresponding angles are congruent, then the two lines must be parallel. Congruent slash equal. Then I've actually shortened this from what I've seen. And again, I'd like to mention I'm not teaching it the way the book is. The book is going to use the same-sided interior angle postulate. I don't know why they did that, but they did. I don't know. I don't know what they were doing. But anyways, so the converse of the corresponding angle postulate, again, I switched the end of the statement with the beginning of the statement. And it says that if corresponding angles are congruent or equal, then the lines are parallel. So, in mathematics, we want to get the first part of the statement to happen, because if we get the first part of the statement to happen, we automatically get the second part of the statement. It's kind of like the buy one, get one free. So if I get this to happen, I get this. And so today's goal and the arguments that I'm going to make is I want to somehow get to the point where I can say that I have corresponding angles that are congruent or equal, because once I get to that point where the corresponding angles are equal or congruent, I can then very easily make the conclusion or reach the conclusion that the lines are parallel. So I'm trying to argue to this because if I can argue to this, I get that. All right, and so that's what I'm talking about when I'm talking about the implication. So what we're going to do is we're just going to see two real short arguments. They were assignments on the lesson, but I figure that I'll do them very quick for you guys. As I erase this, I just want to again say I hope everyone's doing okay. My thoughts are with you guys. And I hope everyone in your family is doing well. So this was our goal, Converse, or this is one of our goals. So again, it's created very simply. Just switch the order of it. All right. All right. So I'd like to just kind of make some quick little arguments. All right. So I'm going to make the claim that if I start with equal alternate interior angles, I'm going to make the claim that I can actually argue the fact that the lines must be parallel. And remember, and that's my symbol for parallel. Remember, I'm trying to argue to the fact that I have congruent corresponding angles, because once that happens, I can make the conclusion that the lines must be parallel. So I'm just going to draw a picture. I don't know the lines are parallel. I don't. All that I can start out with is that I can start out with this. And the only claim that I made was my alternate interior angles are equal. So the only thing I can say is that the measure of angle 1 must equal the measure of angle 2, because this again is what I started with. I started with this. Now in proofs, we say that this is our given. Or you can say you start with it. Now, my angle 1 equals angle 1. Angle 1 equals the measure of angle 2. Those are my alternate interior angles, or alternating sides. And again, notice that I did not put the parallel symbol on this because I don't know that they're parallel. I can't assume that they're parallel. The only way I can get to them being parallel is I have to argue them being parallel. Alright, so I also have in this picture that I have vertical angles, so I can very quickly make the claim that the measure of angle 3 is equal to the measure of angle 2. And by me saying that this is true because they're vertical angles, I've actually again set up my argument style, which is the transitive. And again, remember, transitive is I'm going to have two equations where they're equal to the same thing, so that means that these two must be equal. So I can make the conclusion now, logically, that the measure of angle 1 must equal the measure of angle 3. Now, this is where I wanted to get to, because again, these are my corresponding angles. I got to the point where they are equal. I argued the beginning of my statement. I have now equal corresponding angles. And because I have equal corresponding angles, I get the conclusion of that statement. And that conclusion of that statement is the lines must be parallel. So now I can say the lines are parallel. Okay. So we now know two ways to say lines are parallel. We know that if corresponding angles are equal, the lines are parallel. And now I can say if alternate interior angles are equal, I can also now say the lines are parallel. So just a real quick thing I'd like to point out. If you see these symbols on the angles, that is a way of me telling you those angles are equal. So if you see this, you know that the lines must be parallel. If you see this, you also must know the lines are parallel, because I'm saying that those corresponding angles are equal, which allows me to conclude through a postulate that the lines must be parallel. Now, one more quick argument, and then I'm done for the day. And I know that you guys are probably bored and waiting eagerly for your homework assignment because you took your books. So let me get through this last one. If there's any questions, again, please let me know. This is new for me. I'm sure it's new for you guys. This kind of teaching situation, but again, let's make the best of it as we can because that's all that we can do, and go from there. All right, so I got one last idea that I want to very quickly talk about. I'm going to make the claim that if I start with supplementary same-side interior angles, I claim that if I start with this, that we're going to get parallel lines. Oh, that's not an L. All right, so that's what I'm claiming. That's what I'm going to make a claim. So I want to start off with a picture, and I want to make the claim that the measure of angle 1 and the measure of angle 2 must add to 180. Because again, that's what it means to be supplementary. So that's going to be my starting claim. Again, I don't know if the lines are parallel. I don't know. So let's see here. And this isn't the only way to make the argument. There's actually an argument that can be made. With a different setup. Maybe I can assign that later. But let's I'm saying instead of now. Let's just walk through the argument. So I'm starting with that the measure of angle 1 plus the measure of angle 2, those are equal to 180. They open up to 180 degrees when they're together. They're my same side interior angles. Now notice again I have a linear pair with angles 2 and 3. I can also make the claim that the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And let me just write some things down. I can say that this was given to me. This is what I started with. And this right here, this is true because these are a linear pair. Now, again, I've actually set up the transitive argument where something equals 180 degrees and something else also equals 180 degrees. So what that actually means is that these two things must themselves be equal. And again, you can see that this argument style keeps happening, right? So I'll tell you, when you do proofs, you kind of work backwards a little bit and you see how to connect the dots. I know somehow, some way I need to get these guys together. And I know that these two add to 180 and I know that these two add to 180. And that's my way that I can make my move to get them together by setting up that transitive property. So now I know that these two sides of the equation must be equal. So I can say very quickly that the measure of angle 1 plus the measure of angle 2 must equal the measure of angle 2 plus the measure of angle 3. Now notice that this equation has these two numbers on both sides. Remember, measures are how much they open. And this is a very easy thing to get rid of because if I subtract these from both sides, they cancel out. And I'm left with this. Measure of angle 1 equals the measure of angle 3. Remember, my postulate says that if I can get equal corresponding angles that are in the same position to be equal, that means that the lines must be parallel. So because I got to this part of my argument, I can conclude and I can say with certainty the lines must be parallel. So let me summarize today's lesson. Pretty simple. If you have equal corresponding angles, the lines must be parallel. If you have equal alternate interior angles, the lines must be parallel. If your same side interior angles add up to 180, those lines must be parallel. And remember, we were talking about the converse today where we switch the order of the statement. So we're not starting with parallel. We're getting parallel as a result of what we started with. Now, since I don't see any questions because there's no one in here, I'm here by myself, I would like to assign your homework. And your homework, a good idea, I like my thinking, is 19.3. I'd like you to do problems 1 through 14. Please take a picture of this and upload it onto Google Class. If you have any questions, please let me know. I will post the next lesson tomorrow. I hope, again, everyone is doing okay and hanging in there. I'll talk to you guys tomorrow. Have a good day.